Hello, everyone. Welcome to CloudSec 2020. My name is Riham. I work as a cloud architect in Trend Micro Saudi Arabia. Today, I have my colleague with me, Rohit. He is a solution architect in Trend Micro Singapore. Hello, Rohit. How are you?
Hey, I'm good. Thanks for asking. How are you today?
I'm
And
doing well, thank you.
thanks for the session. Yeah, we can start then.
Let's start because I really interesting about this session, what we have today. So let's start. Let me know what we have.
Yeah. We have today's and everyone else as well. Today's our topic is securing a serverless uh, as a
Nice.
platform.
Yeah.
So okay. So before we go, how we are gonna secure the serverless, let's take a step back and see what is actually serverless. So, in terms of what is a serverless means whenever you are using cloud, uh, you are not thinking about all the infrastructure or operations of where your code is gonna get executed. What what your main concentration is about your code or application itself. So all the operations of like a patching operating system, maintaining operating system, maintaining backend infrastructure, it is everything is a cloud provider's responsibility. Your responsibility is to just provide a code and make sure whatever the configuration you are making for the execution of the code, like for example a memory, environment variables. So these are the basic configurations that you have to make. And whatever the other part is, number of CPUs or backend, mostly is a cloud provider's responsibility. But the next question is, does that means the security is also cloud provider's responsibility? Uh, the answer is actually no. The Yes, partially yes. Some part is like operating system security is the cloud provider's responsibility, but the responsibility of code itself is customer's responsibility. That means it's a shared responsibility model, and you are responsible for your own application and its security as well. Uh, one of
Oh,
the uh, one of the example for serverless is AWS Lambda, or it could be Azure Functions as well. So what we are going to show next is we are going to jump to the demo, and we are going to see like what is a typical application architecture, and I will show the DVSA application. It's a OS DVSA. What is a DVSA means? DVSA means it's a damn vulnerable serverless application. That's a simple full form of the DVSA, and we'll see what is the application. Riham, do you have any question till this point?
the question is just interesting about seeing Lambda and understanding how our application security integrate with it.
Yeah. So we will cover that in next following few steps. Before I go there, I will just show you what is the application. I just want to make sure you guys are familiar with the application itself. So this is the application. I have deployed it on AWS. It's completely serverless application. I will show you architecture of it as well. I will just before that I will show like uh, what is the actual application about. So I have already created a username password in my application. So what happens
Yeah,
is when I click on sign in, the request goes to all the static data is stored on the S3 bucket.
yeah.
That will trigger API gateway, and the API gateway will send a request to Lambda, and Lambda is the actual brain of it, which will process all the requests. So what I will do is, this is, if you see, this is just a normal game store where I can purchase some games. Uh, I will just buy Super Mario. I like it, so I'll just put it into cart. Uh, it's the same like any, online uh, purchase applications. I go check out. It will ask me for shipping details,
Yeah,
and if you see here, that means I'm gonna get a receipt on the email
yeah,
once the purchase is complete. So let me just go here. Of course, the card number is fake. So okay, uh, if you see, the this is a confirmation page. There is a confirmation token.
yeah,
What I will do is I will just copy this token. I will check it out orders. So if you see the status of this order, which we just did, and this is the order ID,
yeah,
it's in the process stage. Let me go to my email box if I got any email. Okay, so my order has confirmed, and uh, I basically gonna get a delivery of my game which I purchased. So this is a simple architecture and simple, simple any serverless application. Let me show the architecture of it, and then we are gonna see that what are the things that you know I can make this application vulnerable with. Uh, Let me just go back here. So this is architecture of the application. So if you see before and after, what does that means? So before serverless, if you wanted to have something like this on the EC2 or server on premises, this is a typical architecture where you have your load balancer, you have your application servers, databases, and it could be data processing servers like processing orders or everything else. And then comes your S3 bucket, which will do like a file storage, probably a receipts file, or if there is any file upload function or those kind of things will be stored on S3, which are like static files. But that's a before part. That means it was, before serverless. Now let's see after part, that just take a use case that I converted my server application to serverless. If you see here, what is fronting is static asset bucket, there is a API gateway, and there is a file upload. What does that mean? Static
yeah.
assets is actually where I will put my all the static files, for example, HTML, uh, or it could be images, it could be web pages. Okay, and those web pages will basically trigger a request to the API gateway. And if application also has a file upload functionality, it will be S3 again. And then uh, there is a database. Then again, there are multiple Lambda. There is a SQS queue into it. So this is a typical serverless application architecture, which is very common.
Okay, so I'm just wondering, like seeing the API gateway, everything has like I am rule. So if we're thinking about the privilege for what we have in here, how to secure our privilege?
That's a very good question. All the cloud providers says as a best practice, you should start with a list privilege principle. What does that means is make sure on all the assets or all the resources you have a least privileges, right? And if you are giving it more privileges, that means you are making your application as well as your infrastructure vulnerable. For example, here if I any of the Lambda has more permission, by any chance if I'm an attacker and I get control of the Lambda, uh, even within the execution stage itself, uh, it could be fatal, that I can basically go and I can create a backdoor account for myself, and then I can get access to entire account of yours, right? uh,
Yeah.
that's that's where the least privileges principle comes, where Lambda should not have access to, create IAM roles or IAM users, those kind of things, because it's just gonna do code processing of application related things. So that's where you should have the policy applied, which is very controlled and very minimalistic policy, and it should not have more access than what it is required. So
Okay.
what we'll do is now, uh, we'll go back to our browser screen, and uh, let me show you the receipt that we got. So this is the receipt we got. Okay.
Yeah.
Okay, so this is the next stage, where we are gonna actually exploit this application, try to get control of the Lambda functions, and to get few more things into it. Before I jump to that, Riham, do you have any question for me?
So I'm just thinking about if we have a first kind of architecture, how it will we like we will be working with.
In terms of a security, if it is related to application security, it's almost similar in terms of application security. Uh, but in the second kind of scenario, uh, for example, the before and after. In terms of a before, attackers can make sure the connection, like a uh, CNC, command and control, is continuously, uh, once they infiltrate the server. For example, if the attackers gets a control of one of the processing server or web server, they can they can continuously make a connection back to their CNC command center. Uh, but in terms of after, Lambda has a request timeout. That means if they get a control of Lambda, whatever the request timeout of the Lambda, within that time they have to do something, or else the connection goes off and the code will be back to whatever it was before. So they have to do it within that time frame, and we'll see that, how that can be fatal as well.
Okay, so it seems really interesting. Can we run a small attack to see how it will be secured or how it will be cut?
Yes, yes. So that's what we are going to do now. So this is the receipt I got, right? If I click on this, my receipt is downloaded and saying that, hey, okay, let me just make it a bigger. Okay, so this is the receipt I got, that I ordered Super Mario. What is my order number? Typical things, right? Uh, but I need to check where this receipt is stored, right? As an attacker, let me just go copy link address. I will go into browser. Okay, I got it. That this is a S3 bucket URL. This is a S3 bucket, so I can try to attack this bucket, I will check if the bucket has over permissions that has provided, because simply if I'm thinking uh, email will, and if the application is storing the receipts on the on the S3 bucket, uh, there might be a case where Lambda is listening to this S3 bucket and which will trigger a email notification. That's a typical architecture, right? In that case, what I will do is I'm gonna check if the bucket has any Lambda listening to it, and if the bucket has over permission, and can I exploit that Lambda function. Okay,
Okay.
so let me just go back to my terminal. So I know this is my S3 bucket, right? DVSA reset bucket and the account ID. So what I will do is I have already created an empty file on this machine. Okay. What I will do is I will try to copy this command over here. So if I break it down into this command, what this command is going to do, it's going to copy the empty file which is on my local drive and try to copy it to this S3 bucket under file name null. And what it is going to do is whatever the output of this shell script, which is echo extra, and if you see in the bracket there is a dollar and ls, it is going to show me the result of ls. So that means I can get the file name. If there is a Lambda function behind this, I can get a file name of that Lambda function. Let's see if we get successful. To read the output back, I'm using a ncroc. Uh, I have already opened ncroc in my on my machine. If you see here, let me just go and okay. So that means file upload is successful. Uh, that means the bucket has over permission. That means anyone can write into that bucket, and that could be a fatal as well. uh, that attackers can generate like a terabytes of file on your S3 bucket, and at the end of the month when you will see your bill for that S3 bucket, you will see uh, you are basically, it's a kind of DOS attack where you are basically getting billed for the things which you are not using, uh, or the things which are you are not utilizing. So if you see here, I got a request that uh, just you can just ignore the 502 byte gateway. And if I go here, I got a name of the Python file which the Lambda is executing. The Python code file name is sendResetEmail.py. So that means now I have more permission that I require for that S3 bucket, and I can get a name of the Python file. Mm, let's see if I can get the application logic or the code of the Python file, right? So I have a command already ready here. What I will do is I will just paste the command. So it's a similar kind of command, except of previously it was only ls. Now I am also doing a cat. So I'm printing the entire code file. Okay. If you see, the file upload is again successful. Let me just go back here. See, there's a new request which came. And if you see, I got a response back into a cryptic language, which is nothing but a base 64 encoding. So what I have to do is quickly copy this, and I have to decode it from uh, base 64 to human readable format. Uh, okay, so now you see, if I go here, so if you see, this is entire
File,
Python code.
entire code.
Yeah, this is entire code of the Python, which I can get. And you can see, it's taking a token, item confirmation, address, email address, and all sorts of things, right? Uh, Now what we'll see is, let's see if I'm able to get the environment variable as well. So let me just go back, and what I will do is I will just edit the same command here. Instead of a cat, uh, I will just put a env. That will print, that should print the environment variables. Okay, again the file upload done. If I go back here, this is a new get. If I go here and copy it, I will again decode it. It's of course in a base 64 format. Here are all the environment variables related to that Lambda function, including,
Oh,
yeah, AWS secret
key.
key.
Oh,
Yeah, yeah. So it has a,
accuracy. Wow. Okay. It
yeah,
seems
it
like
has all the
everything, obvious right now. Like it's easy. The permission for it. It has like reading and write and everything.
Yeah, so if I'm an attacker, what I will do is I will take this access key, secret key, I will take the session token, I will configure it into my local AWS CLI, and I will also try to then exploit it more, where I can create an IAM backdoor. I can create basically IAM user or IAM role, which has more permissions, and I can try to do that and then check if it is successful. Then I can try to exploit that user, and I can using that user itself, I can do a lot of things inside the account. If I have a bad intention, I could probably wipe out the account, or it could be also I can launch a lot of servers with a crypto mining, those kind of things. uh, or it could be other things as well that can be possible with that. So yeah, so this is a attack that can happen with the over permission use case. uh, Now what we will see is how we can block or identify this kind of attack, because this is of course the configuration issues. uh, there are multiple ways to identify it. One is if you have a compliance scan or best practices scan, and it can show you that, uh, hey, the bucket has the right permission, right? Uh, the second option could be, it could be your uh, uh, it could be security of your application itself. If you fix the code, if you fix the permission, and that should also block the things. So for this demo, what we'll do is we'll see the trend micro application security, and we'll try to embed application security with the Lambda code, and let's see if we can block this kind of attacks.
Okay. So right
Yeah,
now we need to do like synchronize between the Lambda function and application security.
yeah. So to integrate application security with the AWS Lambda, uh, there are only three easy steps. So this is a Lambda function, DVSS send receive email, which gets triggered every time there is a report receipt that gets generated. I will show you how to embed it. It's quite easy. You don't have to make any code level changes. It's in three steps. The first step is I need to add a Lambda layer. Okay. I will click on layers. I will add a layer. Uh, I will specify ARN of the uh, Lambda layer, which I got from the documentation of application security. If I go here, I copied this, I filled the AWS region, layer version, Python version, all those details, and I have it ready over here for me. Let me paste it over here. So I have already filled Python version 3.6. Uh, what is the region that I'm using it in, and I will just add. So once I add it, what I'm going to do is the second step. I will put an environment variable, which is uh, key for the authentication for application security. Let me just go to my application security console. I will go to group settings. If you see here, there are keys over here, which I need to configure inside my Lambda. I already copied it over here, so it will be easy for me. In most of the cases, in real life scenarios, this will be a part of your infrastructure deployment, because this is not a code level changes. This is more on the cloud formation level changes, not the actual application code level changes. So I added these two keys into it, which is application key and application secret key, and put it as save. So we completed a second stage. Let me go to the third stage. So what is the third stage is I'm going to change a runtime to a custom runtime instead of Python 3.6. Okay, so I completed all three changes. Yeah, Riham, you had some questions?
No, just keep going because I have a question about malware. So after you finish, I will shoot it because I
Okay,
just want to
okay,
see
sure.
how things will work.
Okay, sure. So let's quickly go. What are the three steps we did? First, added a Lambda layer. Second, added an environment variable, which is for authentication purpose of application security. And third is a custom runtime that we did. So now let's try to do the same thing. Let's see if application security can detect it. So what I'm trying to do, I'm going to do the same env command over here. And let's see. Okay, upload is complete because you remember we haven't changed the permission of the S3 buckets. S3 bucket permission are still open right to the world. I uploaded a file. The Lambda will get triggered. Let's see. Okay, nice. So if you see here, we got a detection over here that says there is a high priority. There was a remote command execution that happened on my Lambda. If I go over here, if you see, uh, on the on the right side, there was more detail about this thread, that what is the action taken is a not block, what is the priority of the attack is a high priority attack, that you need to pay attention to it, that what is the transaction type, what is the invocation type. uh, of course it was a lambda, so the invocation type is lambda. What is the function name that got triggered or got this kind of attack? This is a function name. uh, what is the trigger of it? It is saying that basically there is a sub process that got open, or a child process that got open. Let me just go here and see the view details. So I can see the entire execution details over here.
Wow, it's cool. So that I can share it with other developer or other people who use application security to let them know there is attack like this.
Yes, correct. So I can embed this, and I can tell my infrastructure team that this kind of attack happening. And while finding a root cause, the root cause is actually the S3 bucket which is open to a public. So I can go back, I can fix this on the application side. So now you've seen that it is only the action taken is not blocked, because I have switched it as a reporting mode. If I go to here policies, I can actually change a policy from reporting to a mitigation, to mitigate. And when the next time if the lambda gets executed, it will basically mitigate the attack. It will stop the execution of lambda there and at that moment. So it will not respond back the actual code and everything. uh, so that's how you can actually mitigate the attack as well.
Nice, cool. So I have other question that tells you about malware. Let's say I have a new malware fingerprint and actually like is not updated yet. How I tell other developers like be aware there is a malware.
Yeah, in terms of malware fingerprinting updates, uh, how the application security uh, updates a malware fingerprinting, because of course you cannot, like in traditional environment, can download the malware fingerprints and store it on the local storage, because it's a lambda. And if you download a malware fingerprints and store it locally, once the execution ends, it will basically uh, wipe out everything, and it will be reset to what it was before. In this case, for application security, uh, what we do is actually we are using a lambda layer. So once we update a lambda layer on trend microsite, it gets automatically applied to all the it gets updated to everywhere wherever you are using a lambda layer. So that means you don't have to basically manually go and update the malware fingerprints. It gets automatically done for you.
Cool, nice. So what you said that there is no need to change anything in the code, just I need to add the layer.
Yes, exactly. No need to touch the layer. You just have to add the lambda layer. No changes in the code at all.
Okay, cool. Wow.
So that's it from my side, Rehab. Uh, we have done with the demo. So what we have seen is we see how the even the serverless applications can get exploited, and we see a reporting and mitigation mechanism of it as well.